Hello everybody. This is your practice problems video for special right triangles. I don't have very many practice problems for you here, but I'm going to do a few for you and kind of walk you through these, and that's going to be the extent of this video. Hopefully this one will be a fairly short one. All right. So let's go ahead and jump into it here. Okay. So for number one, we're trying to find these unknown side lengths. So these two go with the 45, 45, 90 triangle. And then these other two here go with the 30, 60, 90 triangle. So we're going to do the 45, 45, 90 one first. So remember I told you the best way, in my opinion, especially when you're first learning these, to do these kinds of problems is to do them this way. So list the name of the triangle, so the three angles, okay? Then list the sides underneath that are across from each of those angles. So for the 45, that has a 34 across from it. The other 45, which is here, has an X across from it. And then the 90-degree angle has Y across from it. Okay, and then right underneath that, write the ratio of the sides. So 1 to 1 to root 2. Okay, so looking at this, I know that 34 is one of the leg sizes. So in a 45, 45, 90 triangle, those have to be the same. The two legs, that's why their ratios have the same number, 1. So that means X is just 34. Okay, and then for Y, remember I told you the best thing to do here. So actually, let's change the color, because I figured out that this was 34. Okay, best thing to do to like not confuse yourself too much as to how to do these, right, is set them up as the fractions and do the cross multiplication, because most of the time you're going to end up with a 1 on at least one of your, like in one of your fractions. So you're not really cross multiplying. Like you don't have a bunch of extra steps to do, if that makes sense. So for example, in this one, if I was trying to find Y, I have Y times 1 when I cross multiply, which is just Y. And then I have 34 times root 2. And I'm literally just sticking a root 2 on the end of the number 34, right? Because there's an understood invisible multiplication sign between those two things, right? So this is 34 root 2, okay? And that's it. That's all you have to do, okay? So let's look at the other triangle type, the 30, 60, 90 triangle, which is over here on the right. So again, write your triangle name out, 30, 60, 90. Write the sides that are across from each angle underneath. So A is across from 30, B is across from 60, and 42 is across from 90. And then the last thing I need to do is write my ratio underneath. So for this one, this type of triangle, the ratio is 1 to root 3 to 2, right? So my advice for you, whenever you don't have a number for the side length above the 1 in the ratio, that you figure that one out first, right? Because it's almost like your baseline, and it makes it a little easier to solve the rest of the problem. So what I'm going to do actually is I'm going to write this A and 1 over here on the right, so you can see like these fractions are supposed to be equal, right? That's the rule. That's how these ratios are set up, right? So I can see that A over 1, which is just A, equals 42 divided by 2, which is 21. Okay, so now that I know that A is 21, I can then use that to find B, right? Because I have 21 times root 3 equals B times 1. right, when I do the cross multiplication, right? And this times 1 basically just goes away, right? Because anything times 1 is equal to itself. So you end up with b is equal to 21 root 3. And that's all you have to do, right? That's it for these two. So A we found is 21, and then B was 21 root 3. Okay. All right. So let's take a look at these last 3 diagrams, which are a little bit more complex, right? You have to use a little bit of logic, and you kind of have to go through and do this a couple of times, right? You have to look at these triangle things a little differently, right? So, okay, so for this one, A, the only piece of information I'm given is that this side here is 9. And I'm also told that these are both 45, 45, 90 triangles. So basically, what I'm going to do is I'm going to use my ratios twice. Okay, so what I'm going to do actually is I'm going to put a little question mark next to this diagonal right here, because that is the leg of the bigger triangle. And what we're actually trying to find is the hypotenuse of the biggest triangle, right? So, but in order to do that, I have to figure out this missing kind of link in the middle first, right? And to do that, I have to use the smaller triangle, right? So remember, I have a 9, and then I don't really know what this other value is across from the other 45-degree angle, but like that doesn't really matter. So I'm just going to kind of put a box there because I don't really need it, right? And then what I'm looking for is the question mark value, which is across from the 90. And then you have 1 to 1 to root 2. Okay, so again, look, if you end up doing the cross multiplication, see how you end up with the question mark is 9 root 2. So that was what I was talking about when I was saying that if we're solving for something and moving from left to right across the ratio, that you end up multiplying. So that question mark value is 9 root 2. Okay, so that means that this leg right here of the bigger triangle is 9 root 2. So we're going to repeat this again using the bigger triangle. And you're going to end up with something that looks pretty similar, right? Except for now, the number across from the 45 is 9 root 2 because we're in the bigger triangle, right? So this is 9 root 2. I don't really care what this is. And then the 90 is the one I'm trying to find, right? The side length across from the 90, that's x. And then again, you have your ratio, 1 to 1 to root 2. So very similar. You're kind of repeating the same process, right? That you're cross multiplying here. Okay, so what you end up with is x equals 9 root 2 times root 2. Whenever you have two square roots that you're multiplying together and the number underneath is the same, that's like saying you have root 2 squared here. So the square root goes away and you're just left with one of these 2's. So 9 times 2, which is 18. Okay, so that's it for this question. Let's take a look at this diagram here. So what a lot of people will try to do is do a similar thing that I did in this first one, right? And work through the, say that it would be the 30, 60, 90 ratio multiple times in order to find their missing value. But you don't have to actually do that, okay? Because if you remember from the notes that I did for you on the right triangle altitude theorem, this is one large right triangle that's broken up into smaller, similar right triangles, okay? But the whole thing, the whole large triangle is a 30, 60, 90 triangle. So I can just do my 30, 60, 90 ratio one time and it'll help me figure out what my x value is. So if I ignore the altitude in the middle and just look at this as one whole large triangle, the number across from the 30 is 8, across from the 60 is x, and then the 90 is like something else, but I don't really care what it is, you know? because it's not what I'm looking for. And then again, my ratio is 1 to root 3 to 2. So when you go through, whoops, when you go through and you're solving for x, right, you're basically cross multiplying here. So you have x times 1, which is just x, equals 8 times root 3, which is just 8 root 3. Okay. All right, last question. So this is talking about a guy who built a birdhouse, right? And they want to know how tall the roof of the birdhouse is, right? Now, this is another one where you may think like you have to go through and use maybe the right triangle altitude theorem or have to do the ratios more than once, okay? But if you take a look at the diagram a little bit closer, it'll be easier for you to figure out what's going on because there's no angle measurements in the diagram at all. But you notice that I have two sides that are exactly equal to each other and a right angle in the middle. So this is an isosceles because this has two sides that are the same, an isosceles right triangle. So automatically, this becomes a 45, 45, 90 triangle. And what that also means is that the small triangles inside are also 45, 45, 90s. So if I have 45, 45, 90, and I'm looking at the smaller triangle, like one of the two smaller triangles, right? The one that I'm looking for, the question mark, is across from a 45, right? And then there's another one, but it would end up being the same, right? And then the number across from the 90 in the small triangle is 18.5, okay? And then again, I have my ratio, 1 to root 2. So if I go through and look at my fractions and my multiplying, right? So there's two ways you can do this. You can do this with the cross multiply thing. So you end up with 18.5 equals question mark root 2. So you have to divide by root 2 on both sides. Okay. Or you could just say, well, I have a question mark value over 1 has to equal 18.5 over root 2. So do you see how you end up with the same fraction that we ended up with this way, right? Because any number or question mark or variable divided by 1 is that same thing, right? So I would just plug 18.5 divided by root 2 into my calculator, right? So if I'm doing this on a cell phone calculator, you kind of have to do it in a different order. You have to figure out what root 2 is first and then do 18.5 divided by that number. So when I did that, I got that the question mark or the value that I'm looking for is 13.08 if you round, and then notice that the question had units in it, so I need to put units in my answer. So 13.08 centimeters. All right, you guys. So that is it for your practice problems for special right triangles. Please reach out if you have any questions or need further explanation. I'll see you guys in the next one. Bye.